Hey everyone, welcome to more examples. So we see here you left off on number 7. Let's do number 8. So I look at this one and say, okay, if I take, let's say I want this u to be down here, say 2x, that's not going to help me get rid of any of this stuff here. So using u substitution for this number 8's not going to be that helpful. Alright, so I can say, what else could I do? Well, let's just do some long division. See if I can maybe rewrite this in a better way that might help what we're doing. So I'm going to take x squared plus x plus 1. And I'm going to divide that by x squared plus 1. Okay, so how many times does x squared go in x squared? Well, it goes in 1 time. Alright, so I've got 1 times x squared. I get x squared. I have plus 0x's and I have plus 1. Okay, so I'm left over with, if I subtract, these cancel out nothing. X minus 0, x is still going to be x, and 1 minus 1 is going to be 0. So I have 1 remainder x. Okay, so what that means is I can rewrite this whole integral as the integral of 1 plus x over x squared plus 1. Got it? Alright, good. So now what we can do is let's just change this to a dx, take the integral of this, put this to a dx, and say, okay, what's the integral of 1? Well, we know the integral of 1, let's see if maybe we can clear this up just a little bit. Does that help? Hopefully it does. And we can say that's going to be x plus c for this first one, right? So there we go. Now let's use a different color just so that we can see this. Right here, I've got, let's say u equals x squared plus 1. So that means du is going to equal 2x dx. Alright, good, because I have an x there, but I just don't have that 2. So if I divide by 2, I can say this is going to be plus that 1/2, that divide by 2 going out in the front, integral of 1 over u du. Alright, that's really helpful because now I can say this is the same as 1/2 natural log absolute value of u plus c. Alright, so let's put this whole thing together. This plus c and this plus c are all going to go together at the end because it's just two constants, so I'm just going to add them together, all the like terms. So I can say this is going to be x plus, and then we have 1/2 natural log. Instead of u, we've got x squared plus 1 plus just 1c, and there we go. And that's pretty much all we've got for this problem. Alright, very good. So now let's do a couple more here. Let's just look at 9, 10, 11, 12, and let's get through these as quickly as possible for you. Alright, let's just do some more u substitution for this one. So we've got integral of 2x over x squared plus 1, or x plus 1 squared dx. Alright, so let's just say u equals x plus 1. And let's say du is going to equal 1 dx. Okay, so now here's the only other thing. I've got an x here that I can't get rid of. So can I rewrite it in terms of u? Well, if u equals x plus 1, that means x equals u minus 1. Right? So now I can rewrite this whole thing as the integral of 2 u minus 1 all over u squared du. Alright, now you say, how does that really help, Mr. Berman? Does it really help? I'm really nervous. Okay, let me help you out. This is what we're going to do. So what we're going to do is we're going to distribute that 2, and then we're going to break it apart into 2 separate integrals. So we can say this is going to be the same as the integral of 2u minus 2 over u squared du. And then we can say that's the same as the integral of 2u over u squared minus the integral of 2 over u squared du. Alright, now I'm kind of running out of room here, so let's just go ahead and do this on another page here, right? There we go. So I've got that. So if I do 2u over u squared, I can say that's the same as the integral of 2 over u. The u's are just going to cancel out, right? This u cancels out with the square, or this u cancels out with the square, right? And now I've got minus the integral of 2u to the negative second du and du. Alright? Excuse me. So now I can just do this as 2 separate ones. 2 over u, well, it's the same as 2 integral of 1 over u du, and now I know that's going to be 2 natural log of u. And then for this one, I know it's going to be u to the negative second, so that means I want to take it up a power, right? So negative 2 plus 1 is negative 1, so I want to say u, oh, okay, let's just write it as u to the negative first, And I have to do what number times negative 1 gives me negative 2. So I'm going to say that's going to be a negative 2 plus c. Okay, so I think we've got it. Now I just have to remember, what did I say that u was? I said u was x plus 1. See, x plus 1. So let's just go back and fill in the x plus 1s for here. We've got 2 natural log absolute value of x plus 1 minus 2 times x plus 1 to the negative first plus c, and that should be our answer. Here's one thing I forgot. It should be minus right here, so minus minus should make it a positive 2. So there we go. You can write it like that, and I think that is just a-okay. All right, so now let's look at number 10. Solve dy dx equals 1 over x natural log of x. So really what we're trying to find is the integral of all that. That way we can say that y equals something, okay? So we want to be able to rewrite this in a much better way. Let's see how we do this. All right, so we're going to use a little bit of trickery here, which is okay to do. We got to be a little creative. That's why this section is kind of tough, because you're not always using the same operation over and over and over again. You're not using the same formula, using the same trick. All right, so we're going to rewrite this as, can we say that's y? Let's say y equals the integral of, what I'm going to do is I'm going to take this 1 over x and just make it the numerator. 1 over x, I can do that, and the natural log of x is still in the denominator, ln of x dx. All right, so now if I think about this, if I let u equal the natural log of x, what's the derivative of that? Well, the derivative of natural log of x is 1 over x dx. And isn't that my numerator? Yeah, so see how by kind of separating this or writing that fraction slightly differently, it really helps, doesn't it? It really does. So we can say y equals the integral of 1 over u du. Okay, and what's the integral of that? We can say y equals natural log absolute value of u plus c. We can say natural log is, or u is just the natural log of x. So we can say y equals the natural log of the absolute value of the natural log of x plus c. All right, now does that seem kind of confusing? Sure, did we do a little bit of a trickery? Sure, but you can do that. You can rewrite this stuff however you want to make sure that it works out to your advantage. All right, now let's do number 11, integral of tangent x. Now you can say, yeah, I know what that is. I can look it up in the front of the book. Of course you can. That's fine, but I want to show you some of the tricks that we can do. Because if I have something and I want to be able to rewrite it, what is tangent? How can I rewrite this? Well, I can rewrite this as the integral of sine x over cosine x dx, right? Okay, good. So now I can say, let's say u equals cosine x, and then what is the derivative of cosine x? Well, it's negative sine x dx, right? I don't have a negative, so I got to put it in. So I got to make sure that I put this negative in, divide by negative 1, or just put the negative out in front on this side, so that way we're all balanced and everything like that. So I can say this is really the same as negative integral of 1 over u du. Okay, so now I can say that's going to be the same as negative natural log absolute value of u plus c, which equals negative natural log absolute value of what is u cosine x plus c. And there you have it. For number 12, you can do this. I don't think I'm going to go through this one just because it's pretty straightforward in the book. I will tell you it is on page 325 in your book. So if you want to see how the integral of secant x ends up being the natural log absolute value of secant x plus tan x plus c, you can. I'll show you, or I guess I won't show you, but the book will show you on how to do that one. It's kind of just involves some more trickery and being able to rewrite some stuff. But there you go. So I hope those are helpful, and I hope that you can use this to help you solve the problems in 5.2. Good luck.